So one of the nice things about derivatives of inverse functions is that we actually have a way of dealing with it without having to get too far into looking for inverse functions when they are kind of hard to find. This is a relatively easy function, but let's take the case that we have a function f of x, which is our function x cubed plus 1. Here it is. And our inverse function g of x, which we know is an inverse by our earlier demonstrations of x, the cube root of x minus 1. All right, given these two functions, what could we say? Well, if we wanted to find the inverse of our function g prime of x, we could find it by taking 1 over f prime of g of x, provided that f prime of g of x is not equal to 0. How would this work out? Well, let's try it out. We know that f prime of x is equal to 3x squared. So if we were to say f prime of g of x, we would in fact be saying 3 times the cube root of x minus 1 squared. So our derivative of the inverse function g prime of x will be equal to 1 over 3 times the cube root of x minus 1 squared. How does this compare with our original? Well, here it is. Let's just compare, because we do know how to take use the chain rule to find the derivative of this particular function's inverse. We have the function g of x equaling x minus 1 to the 1/3 power. We'll write it in exponential notation to make it a little bit easier on us. So by our chain rule, g prime of x is equal to 1/3 times x minus 1 to the 1/3 minus 1, which is negative 2/3 power. Well, if we work that out, we've got 1 over 3 times the quantity x minus 1 to the 2/3 power, and making the observation that we have a cube root that is being squared, we do indeed have g prime of x. Well, this is an interesting result. We can use this to help us find derivatives that might not otherwise be easily found for us if we know a little bit about our one-to-one functions. So we'll do that in our next example.